Alright, so we are now going to have the problem solving related to right triangle congruence. So we're going to apply some of the theorems and formulas in solving congruent right triangles. Okay, now, the first thing that we're going to apply is the Pythagorean theorem. And we know that right triangles have different sides. So the first thing that we're going to do is we're going to label the sides of this. Okay, so the first here, this one is your hypotenuse. So that's C because that is the longest side. Next, this is our altitude and this is our base. So following these letters or representations, the Pythagorean theorem states that c squared is equal to a squared plus b squared. Or if you're going to solve for the value of c or the hypotenuse, so we're going to get the square root of c squared and also square root of this side. Now, let's do some shortcuts. So this will become c is just equal to the square root of a squared plus b squared. So that's the formula for finding the hypotenuse. Okay, next. So if we're looking for the value of the altitude, so that's a, so this will be equal to the square root of c squared, your hypotenuse, minus b squared. Okay, and then if we're going to find the length of our base, so b is equal to the square root of c squared minus a squared. So these are the formulas that we can use applying the Pythagorean theorem to be able to solve for the different sides, hypotenuse, altitude, and then the base. Now, we have here a figure. Okay, so here's the condition that if triangle ABD is congruent to triangle CBD. Okay, find all the measures of the sides of the two triangles. Alright, now, because we have two congruent right triangles, it also follows that the corresponding sides are also congruent or they are equal. So, the first thing that we're going to do is to solve for x. Now, we know for a fact that AB, okay, side AB is congruent to side CB. So, that's line segment AB is congruent to line segment CB. Okay, now, we say that these two sides are equal. So, therefore, we can get the two sides. So, that is 3x minus 4 and equate it. So, equals 2x minus 1. Okay, we do some algebra. So, transpose. So, 3x minus 2x is equal to negative 1. So, plus 4. Okay, next. So, 3x minus 2x is x. Then, equals negative 1 plus 4 is 3. So, we have the value of x, which is 3. Okay, now, we're looking for the measures of all the sides. So, we have already x equals to 3. We can substitute this value to the two sides. So, we have 3x minus 4. So, if AB is equal to 3x minus 4, substitute the value of x. So, 3 times 3 minus 4. So, that will become 9 minus 4. So, that is equal to 5. So, therefore, this side AB is equal to 5. Okay, so next. So, because this is just equal to this side, so, of course, this will become 5 also. But if you want to solve, you may also do the solution process. So, this is CB. Okay, so CB is equal to 2x minus 1. So, that will be equal to 2 times 3. Okay, minus 1. And 6 minus 1. So that is just equal to 5 again. So just the same. Okay, next. So how about CD? Okay, so CD, similar to what we're doing. So you are just going to, again, substitute the value of x. So CD is equal to 5x minus 12. So this is equal to 5 times 3 minus 12. So that's 15 minus 12. So this is 3. So CD is equal to 3. Now, because this side is equal to this side, so therefore this is also equal to 3. Now, how we're going to solve for BD? So, this is already a right triangle, and this is our altitude. Okay, now, following our second formula here, A is equal to the square root of C squared minus B squared. We already have values for our C, okay, and also for our base. So, we're just going to substitute to the formula. So, solving for BD, so let's just use A as the altitude. A is equal to the square root of C squared minus B squared. So, this is equal to the square root of 5 squared minus 3 squared. So, equals 25 minus 9. So, that's equal to 25 minus 9 is 16. And the square root of 16 is 4. Okay, so the value of this side BD is actually 4. So we're now complete. We have already found the different measures of the sides. Okay, so that's the first. Now, the second is, we're also going to apply the distance formula. So if you can see, in our Cartesian coordinate system, or the Cartesian plane, we have two right triangles here. So, this one, GEF, and then XYZ. Okay, now, according to the statement here, prove that triangle GEF is congruent to triangle XYZ. Okay, now, we can only say that these two triangles or right triangles are congruent if their corresponding sides are equal. Okay, so let's see. So, if we're going to get GE here, so the corresponding side of GE is XY. Okay, that's the pair. Okay, next. So, if we're going to get EF, this side, so this will be congruent to YZ, okay, as the hypotenuse. Okay, and then the last we have GF. Okay, so GF, then that will be XZ. All right. Now, so how are we going to prove if these two triangles are congruent? Now, the corresponding sides must have equal measurements. Now, for us to do that, we need to use the distance formula. Okay, and the distance formula is this one. D is equal to the square root of, okay, the square root of the quantity of x minus 2 minus, x sub 2 minus x sub 1, then squared, plus y sub 2 minus y sub 1, then squared. So that's the quantity of y sub 2 minus y sub 1 squared. Okay, so that's the distance formula. So we're going to use this distance formula for every side. Okay, so let's begin with the first. So first, corresponding sides. The first corresponding sides will be GE, okay, or line segment GE is congruent to line segment XY. Okay, so how are we going to do this? You're going to get first the coordinates of point G and point E, and then solve for the distance, and also get the coordinates of X, then Y, then solve for the distance. Okay, so let's first have line segment GE. So the coordinates of G are, you look at the Cartesian plane, the position of the point G, then find the value along the X and then along the Y. So we have 1 and negative 1. Okay, and then you also have E. So the coordinates of E are, so that's 1 and negative 4. Okay, now let's now compute for the distance. So the distance is equal to the square root of your this. So just label. So this is x sub 1, y sub 1, x sub 2, y sub 2. Okay, so let's proceed. So this is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so let's substitute all of the values. So x sub 2 there is 1, then x sub 1 is 1, then squared, plus y sub 2 there is, that's negative 4, minus negative 1, then squared. Okay, so this is equal to, so 1 minus 1 there is 0 squared. So plus negative 4 and then minus negative 1. So this will become positive. Negative 4 plus 1. So that will be equal to negative 3. So quantity negative 3 squared. So that is equal to 0 plus 9. So this will now be equal to the square root of 9, which is equal to 3. So that is the first value. So 3. So this GE here is actually 3. Okay. Now, this side should be equal to this side. Now, let's find x, y. So the coordinates of x are, we have 2 and then negative 4, and then y, 2 and negative 1. So again, label x sub 1, y sub 1, x sub 2, y sub 2. Okay, following the formula again. So d is equal to, now let's just write the values. Okay, following the formula. So x sub 2 will be 2 minus 2 squared plus you have negative 1 minus negative 4. Okay, and then squared. So that is equal to the square root of 0 squared plus negative 1. This will become positive 4. So negative 1 plus 4, that will be equal to positive 3. Okay, so that's positive 3 squared. Okay, positive 3 squared. So next, so 0 squared is 0 plus 3 squared is 9. So that will just be equal to the square root of 9, and that will be equal to 3. Now, so we have found out that this is also equal to 3. So therefore, we are correct that GE is congruent to side XY. Okay, now do this for all the sides. Okay, so you need to solve also, prove that EF is congruent to YZ, and then also the last side, that's GF. Okay, line segment GF is congruent to line segment XZ. So, do the process of substituting, okay, just the same process. You will find out that the values will be the same. So for EF, the distance, okay, will be equal to 5 here. And also for YZ, okay, the distance is actually equal to 5. So you have 5 there and 5 also here. And then, again, doing the same process, so you will find out that side GF will be equal to 4, and then side XZ will be equal to 4. So if you do the computation for the distance, so this will become 4, and this will also become 4. So therefore, we have the same measurements, 3, 3, 5, 5, and then 4, 4. So this means to say that, indeed, triangle GEF is congruent to triangle XYZ by applying the distance formula.